All right, ready to have your mind blown? All right, let's take a look. I'm going to look at what I'm calling the cover-up method. It's from the textbook, and it's a way that, especially if your students have a relational understanding of the equal sign, where this side is equal the same value as this side, that I think they'll really connect with, especially at a young age, even down to 3rd and 4th grade. And so, in this example, you'll remember in the previous video, we combined like terms and then did solving. Instead of doing that here, we're going to cover up our variable, okay? So we're just going to think of this as some number. And we're going to look at how these two sides relate. We see these numbers are pretty close. So 380 and 382 are pretty close to each other. I've got two more here than over here. So if I want these two to be equal, how do these two have to relate? Well, the covered up part needs to be two more to compensate for this two. So this covered up part, this x, has to equal 2 more than 49, which is 51. Pretty cool, huh? All right, but what about more complicated equations? I mean, surely we can't do the cover-up method for something like this. Well, actually we do. We just have to do kind of successive covered ups. So if we look at this and we see 3 times the quantity, 3 times something. Remember we talked about structure before, where we've got 3 times some number? Well, what does this number have to be to equal 33? Oh, well, 3 times some number has to be 11, right? All right, so then I know whatever's on the inside here, that something has to equal 11. So inside was 2x minus 1 has to equal 11. And in fact, I don't need these parentheses anymore. I'm not doing anything. All right, so now I have 2x minus 1 equals 11. So I'm going to cover up this term. You can really see the purple there. Huh. Gonna have to change that to purple highlighter. Oops, I thought I changed it. All right, so we have something minus 1 equals 11. What does that something have to be? That something here has to be equal to 12, right? So whatever's in this blob has to equal 12. So we see that 2x has to equal 12. And finally, I'm going to cover up this 2x. 2 times something. Oops, that's not what I meant to do. 2 times something has to equal 12. What does that something have to be? That something has to be 6. So that blob, x, equals 6. Now, something that's kind of cool is this thinking is thinking about covering up and thinking relationally. But this thinking is really close to what we teach students to do. I'm using a slightly different technique than I did before. But do you see that dividing both sides by 3 is going to end up in this? And then adding 1 to both sides is going to give you this, and dividing by 2 is going to give you this. So we've gone using a cover-up method that is relational, builds on what students know, and it goes right into the algebra method. I think that's fantastic. All right, last one here. Let's take a look at this equation. Remember before we had all those nasty fractions? I normally like fractions, but not in that problem. Okay, so let's look here. And some of you probably saw a shortcut here, to be fair, noticing that these were the same. But let's look here. In this case, if you look at it and you see, hey, I'm going to cover up this blob. Okay, that term. So I've got 5/16 plus 2/3 equals something plus 5/16. What does the something here have to be? Well, the something has to equal 2/3. And so we see that that was 2/3. And now we can take it a step further, cover up this blob, and say 2 times what gives me 2/3? Well, if I have 2 of them to get 2/3, this blob must equal 1/3. Because 2 1/3 is going to give me 2/3. And so x equals 1/3. Now, will this cover-up method always work? No, it doesn't work real well when there's different x's on both sides, or if the problem's not set up quite as, evenly. And so there's a place for algebra, but we want to bridge that gap between what makes sense to them to the algebra methods that don't make sense to them right away. So that is the cover-up method.